Hello and welcome to part two of my pre-calculus progress check review. Today we're going to be talking about progress check unit 1, topic 2, formative assessment 1. This one is fairly quick. It is only just 2 pages. You'll also notice that there are no calculators available for this one. So if you are pretty calculator dependent, you might be a little out of luck. So let me go through the first one. So it says, which of the following could be the graph of f of x is equal to 2 to the x, 2x to the 2/3 power. Now, a couple things to note. If I end up taking, let's say, a value that is inside this, for example, right, because we can actually rewrite this as the cube root of x squared. But if we end up, let's say, plugging in 1 or x is equal to -1, we know that when we square something, we're always going to get a positive value. So I don't care too much about the 2 too much, right? Because there are technically no scales for this graph. I just need to know whether it's going to look like one of those specific types of shapes. So the thing that I look for is I look for that squared part. And if I have a squared, that means that this -1 is actually going to become positive. And if I end up having, like, let's say, -2, that's going to be +4. So we know that we're always going to get a positive y value out of this, unless if the 2 ended up having a negative value in front. So I can already rule out a whole bunch of values. So for example, can I plug in -1 into this? So if I do 2 times -1 to the 2/3 power, that ends up giving me, let's say, the cube root of -1 squared. And we know -1 squared is actually going to give me 1. Cube root of 1 is going to also be 1. So my answer will actually be 2. Now, we can also eliminate a couple of our choices from this. For one, we can eliminate D, because there is no -1 value at 2. So there should be a value at -1, but there's only values from 0 and on, from the looks of the graph. The second thing I can already eliminate from this is the letter B. I can already eliminate B because we see that this graph right here dips down below the x-axis, which means that we're going to get a negative y value. Well, there's no chance that we're going to get a negative y value when we have, let's say, an x squared. So now we're down to two different options. We're down to A and C. So the thing about C, for example, it looks like they have a vertical asymptote right smack in the middle. So which means that this graph, in a sense, has some type of fraction. But the only fraction here is actually the power. If this was, like, let's say 2 over x, then we would say that we have an asymptote at x is equal to 0. But since we don't have that, right, we actually have a value at x is equal to 0, right? So that'd be 2 times 0 to the 2/3, which, 0 to the 2/3 is just 0. 0 times 2, which is going to give me 0. So my answer is going to be A. Move into the second one. Notice how there is a negative exponent here. Okay, so that will give us some insight about what is actually happening with this problem. So I'm going to rewrite the problem as 3, right? Because the 3 is technically not being affected by the exponent itself, only the x. So we're going to say x to the 3/4. Now I'm going to also rewrite it another way. I'm going to say the 4th root of x to the 3rd power. Now, something to keep in mind, if I have, like, let's say, a square root of -1, we know that this is not a real solution. So not real solution. Right, we know it deals with imaginary numbers, but since we're working with graphs and we're working in a 2D plane, we're not going to worry about some of the complex numbers or the imaginary solutions. So what ends up happening here is I can't actually plug in any negative numbers in here, because if it is a square root or a 4th root or a 6th root, right, we can't yield a negative number. So that means that this one right here, where we have negative x values, same thing over here, we have negative x values, those ones aren't going to work for this. So those two are out. The next thing I notice, since this is an actual fraction that I kind of noticed from before, right, I don't actually have a value at x is equal to 0 because I have a vertical asymptote. right? X can't technically be equal to 0. But what ends up happening is that doesn't really kind of yield one solution or the next because, well, they both actually look like they have vertical asymptotes. But the thing I do notice here is that if the y value is in a sense positive, it's going to be the graph D. If the value yielding is going to be negative, then it's going to be letter B. So if I were to choose, let's say, x is equal to 1. So that means right here, right at 1. Will I yield a positive value or a negative value? And in this case, picking whichever graph that I wanted to plug into, it's going to be 3 over technically 1, or 1 to the 3/4. But 1 to the 3/4 is really just going to yield 1, so my answer here is actually most likely going to be D. Okay, moving on. So it says, which best describes the symmetry of the function f of x is equal to 2x to the 3/5. So what ends up happening here is if you're looking at both the numerator and denominator of the exponent that is tied with x, if they are both odd, that means that this is going to be an odd function. That means that you can pull out a negative. But if, let's say, the numerator was even or the denominator was even, then things actually change depending on whatever the value is. So for example, if I end up having, let's say, 2/3, right? What ends up happening is that this 2 actually makes that x a positive value. So it actually makes this actually makes it an even function. But if I end up having, like, let's say 3/2, right, this actually makes it not an even or an odd function because really this means square root of x to the 3rd power. And we just talked about in our last problem that if we end up having, let's say, a square root, a 4th root, a 6th root, we can never have any negative values, so it's neither odd or even. And when I mean odd or even, that means that it has either even symmetry or odd symmetry. So even symmetry means that we end up having a reflection over, let's say, the y-axis. So that would be even symmetry. Or odd symmetry ends up having what we call rotational symmetry about the origin. So that means that if I end up rotating this 180 degrees, then the figure actually ends up kind of overlapping on itself. So in this case, so going back to the original problem, so 3 over 5, if they are both odd numbers, then the function actually itself is going to be odd. Okay, which function grows at the fastest as x approaches infinity? So I do not actually care about the first number. The first number is insignificant. We do not need to worry about it. What we do need to worry about is the exponent that is tied with the x. And whichever has the highest value is going to be your answer. And so in this case, c being x to the 7/3, right, it's a little bit more than 2, is actually our highest exponent. So c is going to be our answer. Okay, so the next one says the function f graph below is a power function of the form f of x is equal to x to the a power. The graph of g is a rigid transformation of the graph of f. So it says write one possible value for f. Since I know that it dips down into the negative, comes back up, and looks just like this graph, I'm going to say that this would be most likely a cube root function. So that would be cube root of x, but that's not in the form of a power function. So I'd write this as x to the 1/3. So what would be one possibility? 1/3. But actually, to be honest, you could say 1/5, 1/7, 1/9, because the 5th root or the 9th root or 7th root of 1 is still just 1, right? That doesn't actually change. The next thing that I notice here, it says write a rule for g based on the answer from number 5. So the hint here is that it is a rigid transformation. So that means I'm going 1, 2, excuse me. So 1, 2, 3 units over, and then I'm going, looks like I'm going 1, 2 units down. So from this origin, 1, 2, 3, and then 2 units down. So I'm going to write this as the following. I'm going to say the cube root of x. Now, if I want to go 3 units to the right, I'm going to write that as x minus 3. And if I want to go 2 units down outside of the radical, I'm going to write minus 2. and that's going to be our function. Now, I could double check the other point, but really, to tell you the truth, that is also going to be perfectly matching up, right? If I choose 4, let's say I'd choose 4 cube root of 4 minus 3, and then minus 2. This is going to give me the cube root of 1 minus 2, and that's going to give me negative 1, right? And that ends up giving me my y value that I want it to be. Okay, so it says y varies inversely as the square root of x, and y is equal to 2, and x is equal to 25. Write y as a power function of x. So how this problem goes is I can write this as y equals, so k over, so this really means the inversely kind of function. So this would be y is equal to k over x, or you can sometimes write as xy is equal to k. So where k is some type of constant that changes. So with these types of problems, normally you try and figure out these specific values, get a k value, and then write the equation based around the k value, whatever the constant is. But in this case, we're saying that x is actually going to be a square root of x, so I'm going to write my equation as y is equal to k over square root of x. Place in my y and my x value, so I'm going to place in 2 for y. I'm going to write k over square root of 25. And so what I end up getting here is I get 2 is equal to k over 5, multiply both sides by 5 to get the 5 from the denominator, and I get 10 is equal to k. So I could write this two different ways. I can write this as y equals 10 over square root of x, or I can also write this as y is equal to 10x to the negative 1/2, which I'm guessing is the form that they wanted it because they want it as a power function. So a power function means that we have some type of constant, we have our variable, and then raised to some type of exponent. Okay, hope this was informative. Thank you again for watching. If you have any questions, please comment down below, and thank you for watching.